Hello everyone, tunia hi physics motion in 1D last topic na relative motion ibolde hin hi video zo phale hin video chombele relative motion mama 2 dimensions ana che ibolde hin tin. So before going into relative motion, so small point physics frame of reference ti naza kha deu chuna. So frame of reference chupi ke saina ham. So what is frame of reference? Say suppose you are sitting on a roadside, right? You're sitting on the roadside and then you're watching vehicles moving. Car, bus, like velocity. Suppose if I say car is moving with 5 meters per second with respect to you, then in the car had done 5 meters per second. Ground so you're sitting on the ground, so the ground is not moving. Okay, wherever you're sitting, that frame is not moving. So with respect to the ground, so the speed of the car is 5 meters per second. Okay, so I can say that the speed of the car with respect to the ground is 5 meters per second. Suppose you have a road. A car is moving 5 meters per second. Okay, you're sitting on the roadside. Ground on not the one of it. So not cars of 5 meters per second. It's a speed by so this is the speed of the car, or you can say velocity of car with respect to the ground. Okay, right? If you are sitting on the ground and watching that car, so that is velocity of car with respect to the ground. It's like case frame of reference na frame pa na ground so here you have a ground frame. Okay, ground frame is what this is the frame of reference. So the frame from where you're observing the motion. Okay, so that is your frame of reference. You are staying on the ground and then you're looking at the lift building sangta ta lift gampama building 2 pita ta lift ki mozi chula na pola para bezong. Suppose the lift is moving up. Okay, so here with respect to you, let's say it is moving with 5 meters per second. Let's say 5 meters per second. So this is the velocity of lift with respect to the ground. So here the velocity of lift with respect to the ground is 5 meters per second. Okay, so first frame of reference, so ground frame. Another example. Suppose you are also in another lift. Okay, and there is another lift here. Suppose that lift is going upward with a meter per second square, and the same way lift so that is also moving with a meter per second square acceleration. Okay, both of them are moving with the same, you can say same velocity. They are moving together. With respect to you, frame let's say AB na A na B na B pa velocity to so that is the velocity of B with respect to you, with respect to A. Okay, because you are in A, so the velocity of B with respect to A. So what do you think this is? So with respect to you, the leaf will not be moving. Okay, it will not be moving. Okay, so here velocity of the other leaf with respect to you is 0. I have a ground up on velocity. If you are from in the ground and you look at that leaf is so here the velocity of leaf B with respect to the ground, so this is not 0. Okay, so the leaf will be moving with some velocity if you're standing on the ground, but if you're standing on the leaf A here, so leaf A and leaf B are moving with the same speed, same acceleration. Okay, therefore with respect to A, B will not be moving, it will be stationary. Leaf anomalchun frame of reference to so leaf A. Okay, so if you're sitting in the leaf A and watching B, so your frame of reference is leaf A. If you're standing on the ground on a leaf B frame of reference to so that is ground. Okay, so if the frame of reference is ground, you say velocity with respect to the ground. Okay, if your frame of reference is A, you say velocity with respect to the A. Nah. Okay, so basic frame of reference. Kutile another example. Suppose you are moving in a car. Okay, let's say car A na. Car A here, let's say is moving with 10 meter per second. Abanacho another car is here. Say car B. Car B is also moving with 10 meter per second. Kutile car A hin tawin lang. Okay, car A hin tawin lang. B equivalent a chang them. So what is the velocity of B with respect to A, with respect to U? So here A hi 10 meter per second achia, B zong hi 10 meter per second achi. Kutila speed on chuki bang na. So that means here you will observe that B is not moving. Okay, not moving closer to you, not moving further away from you. Okay, your speed are same. So with respect to you, B will be at rest. So mathematic na. So in mathematically, how do you write this? So whenever you are asked to write velocity of A with respect to B, so the way to write this is VA minus VB. You only have one formula in relative motion. Okay, so this one. Velocity of A with respect to B is equals to velocity of A minus velocity of B. Okay, so that is the formula. Chila hinga apply leo hen. Velocity of A chupe ham, so 10 meter per second, minus velocity of B chu ham 10 meter per second. So how much? 0. Okay, so here velocity of A with respect to B is 0. With respect to B, that means the frame of reference is what? Okay, if you're sitting, see, VAB means if you're sitting at B and looking at A. Okay, and similarly you can write here VBA is velocity of B with respect to A. So here VB minus VA. Okay, so this is how you write now. First case pa here. So when you say velocity of A with respect to B, so here what is your frame of reference? Frame of reference is B. Okay, you are sitting in B and observing A. So if you say velocity of B with respect to A, so here the frame of reference is A. The frame of reference you are think of yourself as A. Okay, and then you're watching B. Okay, so now if I have a car, so say this car is moving with 5 meter per second, car A. Say there is another car. Okay, so this car is moving with, let's say, 10 meter per second, car B. Question 2, what is the velocity of B with respect to A? Okay, what is the velocity of B with respect to A? So A to frame of reference na, you are sitting at A and then you're observing B. Okay, velocity of B with respect to A. So velocity of B minus velocity of A. Velocity of B to 10 minus velocity of A to 5. So this is 5 meter per second. So what is this 5 meter per second? See, 5 meter per second here. So that means if you sit at A and watch B, so B is moving 5 meter per second. Plus 5 meter per second minus 5 meter per second. That means it is moving away from A with 5 meter per second. Okay, away. B is moving 5 meter per second away from you. Okay, away from you. So if you sit at A and observe B, okay, so B is moving with 5 meter per second away from you. So the place where you're sitting is your frame of reference. So when I say velocity of B with respect to A is my frame of reference. Okay. So one more. I have a car. So let's say this is moving with 10 meter per second. I have another car. Okay, so this car is moving 12 meter per second towards the left, coming towards, okay, let's say A and B. Kutile, what is the velocity of B with respect to A? Right? If you sit in A and what's B, so how will B look like? What will be the speed of B? So the motion of B, how will it look like? So here I can say VBA. So velocity of B with respect to A is velocity of B minus velocity of A. Okay. So how much is this? Velocity of B2. So here you see B is going towards the left side. Okay. If you draw XY axis, so here B is going towards negative x-axis. Okay. So here I have to write minus 12 minus, so 10. So this is minus 22 meter per second. So here, what is minus 22 meter per second? So this means A will see that B is coming towards him with 22 meter per second velocity. Okay, so that is what it means. Okay, similarly, another example. Let's say a person, right? A person is walking. So this person is walking with, say, 2 meter per second. Another person is say 5 meter per second. Another person is moving with 2 meter per second, right? So person A and person B. So how will person B be observed by you? B pa motion ju itabang hindam. So velocity of B with respect to A. So velocity of B minus velocity of A. B chu zanham 2 meter per second, A chu zanham 5 meter per second. Okay, so this is minus 3 meter per second. So what is the meaning of minus 3? Minus 3 kiti chu, if you are A and you observe B, so even though B is with respect to the ground, it is moving 2 meter per second, but if you are moving faster than B, you will observe that B is coming towards you, closer, okay, closer to you, with the speed of 3 meter per second. Okay. Suppose I have a person walking. Say this person is walking with how much shall we take? 1 meter per second, okay, towards the right. And here I have a bus, right? So there is a bus coming towards that person. The bus here, let's say the speed of this bus is how much shall we take? Say 3 meter per second. Okay, so bus is coming 3 meter per second towards the person. Say the length of the bus, okay, let's say this is how much? I'll say 20 meter. Meter is so many meter. 20 meter is very long, right? So let's say here 12 meter. Okay, so I think 12 meter is reasonable. Okay, so 12 meter bus is coming towards the person. Here, what is the question? The question is, how long will person takes to pass the bus? Dang mi pahin bus chu apial de solana apial de hung kaya. Hichi apial ka songa chu time is a ludam tinai chu. Okay, so how long person takes to pass the bus? See, what you can do is hita hi bus na. So you can say that when person tang bus mi pahin bus yan pa phala chun mi pa chu yam ha. So mi pa chu chalai am chu chalai. So now you have to see. So mi pa chu chilanga hai 1 meter per second achia, bus chu chilanga hai. So it is going with 3 meter per second. So here you think of yourself as the person and then you're looking at the bus, right? So what is that? Velocity of bus with respect to the person, say P, right? So this is velocity of bus minus velocity of person. Velocity of bus so always assume that this is the velocity of bus with respect to the ground, okay, ground frame. So velocity of bus to minus 3 minus velocity of person to 1, so minus 4 meter per second, right? So this is their relative velocity. Okay, Na mi pa chu race a ma la chun, suppose if the person is at rest, so the bus is moving with 4 meter per second, right? Mi pa hin chilai pa hi chilai si abon cha ke pha ngai chu a ho khal ngai na pass ngai, so the person has to pass through all this up to this much distance in order to pass the bus. Bus cho pial do na ding na distance a cover this is anam, so this much, so this is 12 meter. Okay, so that means this bus has to travel 12 meter to pass through the main. Ale la nga zona sai na bus chun mi pa chu a pass na ding na a pial na ding chu things la pial na ding na, so how much distance hotel distance na, so this length of the bus. Okay, so 12 meter. So here the bus is passing through the person with 4 meter per second and the length of the bus is 12 meter. So how much is the time? Time is that so here time will be, so 12 divided by speed to 4, 3 seconds. Okay, so the person will take 3 seconds to pass the bus, or the bus will take 3 seconds to pass the person. Na mi pa pial na ding 3 seconds ngai ti nei cho. So let's solve one question. A train A is moving along 2 parallel tracks towards the north. Train A. So train A is going towards north. North is southwest. North. So this is north, this is south, this is east, this is west. So here it says A is moving towards north with 72 kilometer per hour. Okay, he kilometer per hour he meter per second I convert him, so you multiply by 5 by 18. Okay, zadingham to 9 2 are 18, 9 8 are 72, to 2 are 4, so 5 4 are 20 meter per second. Abanasa PM. Train B is moving south with 108 meter per second. Okay, you have another train B, so this is moving south 108 kilometer per hour. 108 choose 108 into 5 by 18, right? So how much is this? 6. Okay, 8 6 are 48, so 6 5 are 30 meter per second. B2 A to A, B is towards A and then A is towards B, so they are approaching each other, right? So velocity of B, first question, velocity of B with respect to A. Velocity of B with respect to A. Okay, so how do you write it? Velocity of B with respect to A. So this is velocity of B minus velocity of A. B choose hum minus 30. Na aji jo chilang hi minus kila chilang ho plus kila. So minus 20. Okay, so the direction of A is taken as positive. Direction of B is opposite to A, is negative. Okay, B is going backwards, so with respect to A it is going backwards, so minus, and A is taken as plus. So here how much is this? Minus 50 meter per second. Okay, so velocity of B with respect to A is minus 50 meter per second. Abana so we have velocity of ground with respect to B. Okay, so how do you write it? So velocity of ground with respect to B. So this is velocity of ground minus velocity of B. Ground frame as a ground to be 0. Okay, so ground is not moving, right? So ground is 0 minus velocity of B to be minus 30. So minus minus is plus. So 30 meter per second. Okay, so which option? Option B. Moving on. So another J question. A passenger sitting in a train A moving at 90 km per hour observes another train B moving in opposite direction for 8 seconds. Okay, if the velocity of the train B is 54 km per hour, then the length of train B is. Okay, you have train B, train A. Say it is moving with 90 kilometer per hour. 92 is at the hum, so 90 into 5 by 18. Okay, so this is how much? 5 are 25 meter per second. And then you have another train B approaching train A, 54 kilometer per hour. Okay, so how much is this? 54 into 5 by 18. So this is 5 are 15 meter per second. Question 좀 비키피야. So a passenger observe. Passenger to meet. Oh, so here you have one person, passenger. Here train. Okay, train is very long. So let's say the length of the train is L. So lang example, mi pato bus question important. So it is exactly like that. Okay. So here a person is observing. A is a person, and then it is observing the train B. Okay, B is the train. Kutile mi pa question. So mi person train so it takes 8 seconds to pass. Na mi person, see, if this is a person, so the train is moving like this. So the train takes to pass this person B, person A. So the train takes 8 seconds. Okay. See, length is so for the whole length of the train to pass through this point. Okay, so it takes 8 seconds. So imagine yourself the person. So what is the velocity of B with respect to A? So the velocity of train B with respect to person A. So velocity of B minus velocity of A. B2 minus 15 minus A2 25. So this is minus 40 meter per second. Okay, A will see that B is coming towards him with 40 meter per second velocity. Okay, and then to pass through the person has to cover all of this length. Okay, this length L. Time to pick up L by V, speed to 40. Okay, so time is 8, right? So 8 seconds L by V. So what is L? Length of the train is 8 4 are 32. So 320. So one more question. So this question is from H.C. Verma. So the question is, a car is traveling 60 km per hour overtakes another car traveling 42 km per hour. 60 km per hour, so 60 into 5 by 18. So this is 610, 63. So 50 by 3. Okay. So here you have 42 into 5 by 18. 6, 7 are 42, 6, 3 are 18. So 35 by 3. So this is meter per second and this is meter per second. Okay, here you have a car. So this car is moving 50 by 3 meter per second. So another car is moving with 35 by 3 meter per second. Speed. So it is going to overtake the second car after some amount of time. So the length of its car is given as 5 meter. So find the time taken during the overtake and the total road distance used. Onki overtake part nunga car pahi, let's say this is car A and car B. So when car A reaches, you see what will be the situation? Okay, when car A reaches the other car, so it will be like this. So at this point, the car A just reaches car B. Okay, and then overtake type halation. So once it overtakes, so when do you say car A will overtake car B? So when the situation is like this. So now you have car B and car A. Okay, Kutile atila chu car A hin hitai chi na. So car A after some time it will come like this. So car A will be here, okay, and then after some time car A will be here. So only then we say that it overtakes. So to overtakes, how much distance it has to travel? So 5 plus 5. Okay, so total is 10, right? So car A, if you see the tip of this car, okay, so tip of this car, so here it is here. After some time when it overtakes, so the tip is here. So that means total distance is what? 10. Okay, so that means it will cover 10 meter. I mean overall is 10. Okay, 10 car and length combined as 10 jala. So here first let's see the velocity, relative velocity. So here I am A, I am seeing B, so velocity of B with respect to A, so that is velocity of B minus velocity of A. Okay, so 35 by 3 minus 50 by 3, so how much is this? So this is 15 minus 15 by 3, so this is minus 5 meter per second. Okay, so the relative velocity is minus 5 meter per second, and this 5 meter per second has to cover how many distance? 10 meter cover. Okay, you can think of this as 5 meter per second motion traveling 10 meter. Okay, so what is the time? So 10 by 5, so 2 seconds. Okay, so it will take 2 seconds to overtake, right? About the question in PWM, total road distance. Okay, how much total road distance? Distance equals to speed into time. Okay, so here road distance never ding while a road to ground. So now everything has to come into with respect to the ground. Okay, so here I have to write x equals to speed into time, speed pahi, so velocity of A with respect to the ground into time. Okay, so that is how much? A to 50 by 3 into time to 2 seconds. Okay, so here you'll have 100 by 3 meter. Okay, so this is the amount of distance covered to overtake during the overtake. Okay, so that much for relative motion 1D part. Okay, so here we can see that most questions so far is asked in 1D, and there is also 2D part where you have river boat problem ho na, swimmers problem ho, chale rain problem ho. Okay, so those things we will learn in the next video on the motion into the part. Okay, so that much for this video. We'll see you in the next one.